Welcome to this tutorial on sorting arrays using NumPy sort function. In this video, you'll learn how to sort arrays in ascending order using np.sort, which is one of the most commonly used functions for organizing data in NumPy. np.sort is a NumPy function that returns a sorted copy of an array in ascending order. The key thing to understand here is that it creates a new sorted array without modifying your original data. This non-destructive behavior is important when you want to preserve your original dataset while working with sorted versions. The basic syntax for using np.sort is straightforward. You simply call np.sort and pass your array as an argument. This simple syntax will return a new array with all elements sorted in ascending order from smallest to largest. Let's see a practical example with a one-dimensional array. We create an array containing the numbers 5, 2, 8, 1, and 9. When we apply np.sort to this array and store the result in sorted_rr, we get a new array with elements arranged in ascending order: 1, 2, 5, 8, 9. Notice how the function automatically organizes the numbers from smallest to largest. An important characteristic of np.sort is that it doesn't modify the original array. Using the same example, when we print the original array RR after sorting, it still contains 5, 2, 8, 1, 9 in the exact same order. The sorted version exists only in the new variable sorted_rr. This is crucial when you need to keep your original data intact. np.sort also works with two-dimensional arrays. By default, it sorts along the last axis, which means it sorts each row independently. In this example, we have a 2x3 array with 2 rows. The first row contains 3, 1, 4, and the second row contains 9, 2, 6. After sorting, each row is sorted separately. The first row becomes 1, 3, 4, and the second row becomes 2, 6, 9. You can control the sorting direction in multidimensional arrays using the axis parameter. When you set axis equals 0, np.sort will sort along the columns instead of rows. This compares elements in the same column position across different rows. In this example, setting axis to 0 sorts the values vertically within each column, giving you more control over how your two-dimensional data is organized. Let's recap the key points. First, np.sort returns a sorted copy in ascending order, organizing your data from smallest to largest. Second, the original array remains unchanged, so your source data is always preserved. Third, use the axis parameter for multidimensional arrays to control whether you're sorting rows or columns. Understanding these fundamentals will help you effectively organize and analyze your NumPy arrays.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.